CIET NCERT presents the audiobook Kaushal Bodh, textbook of vocational education activity book for grade 6.
Page 55, Part 2, Work with Machines and Materials. Machines make our lives easy and materials are all around us. Projects on work with machines and materials will help you work with different machines and tools to create new things with different kinds of materials and to repair and maintain things. You can take up projects related to making electronic toys, carpentry products from wood and bamboo and pottery products with and without using a wheel, sewing clothes, decorating fabrics, using computers and smartphones to make games and animations, and using waste materials to make toys or even instruments for a school band. It is up to you imagine all that you can do with your peers. 2 examples of projects are given in this section. You must take up only one project. You can either choose one of these projects or you can design a project of your own choice with the help of your teacher. Page 57. Project 3. Maker Skills. This project will help you learn about simple machines that make work easier. You will develop skills to create toys from waste using simple machines and then explore the various simple machines used in a bicycle. You will also learn how to maintain and repair these machines to keep your bicycle in a good working condition. As part of the project, you will be able to learn about simple machines, make toys from waste using simple machines, learn to maintain and repair a bicycle, learn about simple machines in a bicycle. Figure 3.1. Making things out of waste material using tools. In this page, there is an image in which school students are making different objects using waste materials and using tools. Page 58. There are many things around us which are complex machines, such as bicycles, toys, buses, cycle rickshaws and auto rickshaws. We use doorknobs and open and close doors and windows without thinking. But how do these things work? All these things have simple machines in them. For example, wheel and axle and pulleys are simple machines. Simple machines help make our work easier. They help us to do things beyond our capacity, which are difficult or simply not possible. For example, can we lift heavy loads or break wood with our hands? A cart with wheels and axle can move very heavy objects with less force. Pulleys can lift heavy objects. Do you know that even a big bus is actually made up of many interconnected small machines? And that the simple machines used in a bus are also used in bicycles and toys and doors and windows. Yes, it is true that they are made up of simple machines. Look at figure 3.2 below and discuss what else simple machines can do. Figure 3.2. Simple machines around us. In this page, there are various images of simple machines. For example, inclined plane, wedge, lever, wheel and axle, screw, pulley. In this project, we will first learn how to use simple machines to make simple toys. This will help us understand how these machines work. We will then identify the simple machines in a bicycle and how to keep them functioning well. Page 59. Figure 3.3. Simple machines have been in use since ages. Ancient people used inclined plane, figure 3.3a, and pulley, figure 3.3b, to transport heavy materials. In this page, there is an image of ancient people constructing a building using simple machines like inclined plane and pulley. Ancient architecture. Huge stone temples in ancient India were constructed using a combination of skilled labor, simple tools and machines, and clever engineering techniques. The process often involved quarrying and transporting large stone blocks, carving and shaping them, and then assembling them in the desired structure. Workers used basic tools like chisels and hammers to carve the stones. They also used various innovative methods for lifting and placing the heavy stones, such as using inclined planes, levers and pulleys. These are all simple machines that we use till today. What will I be able to do? At the end of the project, you will be able to 1. Make toys from various materials using simple machines. You can make catapult, robotic arms, elastic band propeller, boat, balloon car, rubber band car and windmill. Page 60. 2. Identify the various simple machines that make up a complex machine, like a bicycle. 3. Identify the main parts of a bicycle and their functions. And 4. Identify common problems with bicycles such as flat tires and misaligned brakes and perform necessary maintenance and repair. What will I need? For making toys from trash using simple machines. Materials required: cardboard, plastic pipe, empty plastic bottles, cardboard, plastic spoon, drinking straws, plastic bottle caps, paper, ice cream sticks, thread, rubber bands, glue, tape, glue gun, cellophane tape, clothes clips, all pen, balloon, color box, chopsticks. These could be of wood, plastic or metal. Tools required: scissors, meter scale and cutter. For learning about simple machines in a bicycle, you will need at least 5 to 6 bicycles. Materials required: oil or grease. Tools required: spanner set, wrenches, chain brush, tire levers and air pump. You will also have to visit a bicycle shop or request someone who can repair a bicycle to come to the school to teach you. How do I keep myself and others safe? Point 1. Be careful with cutting tools and other sharp edges. Point 2. Ensure that you clean the area after you finish an activity and store materials and tools as per the instructions of your teacher. Point 3. While using the toys, ensure that you do not hurt yourself or others. Page 61. What do I need to know before I start? Can you identify simple machines in your surroundings? Look around. See what you can find. Activity 1. Simple machines in our surroundings. Identify everything around you that helps you do something. Find out if it is a simple machine or if it is made up of simple machines. You can ask your teacher or your friends and family for help. Write your observations in Table 3.1. Table 3.1. Simple machines around us. In this table, you can write the name of the simple machines and how they are used. For example, 1. Knife. It is used for cutting vegetables and fruits. 2. Vegetable peeler. Used for removing peels of fruits and vegetables. In the same way, you can write the name of many other machines and how they are used in the given rows 3, 4, 5 and 6. Page 62. What I have to do? First, you will make toys using simple machines and then identify the simple machines in a bicycle. Next, you will learn how to maintain a bicycle. Learning on the internet. You can look up the steps to make the toys given in the activity book by searching on the internet and the search keywords DIY plus XX. Name of toy. DIY means do it yourself. If you want to see videos, you can add the word video to the search keywords. Internet safety. Ask your teacher for help while using the internet. Be careful not to upload or download anything and do not share personal information anywhere. Activity 2. Using levers to make toys. A lever is a fixed bar or handle that moves around a fixed point called the hinge or fulcrum. A simple example of using a lever is when you use a spoon to open the lid of a tin. The tip of the spoon is fixed under the lid and you apply force at the other end. Another example is that of a seesaw in the playground. Some toys you can make using a lever are catapult, lazy tongs and robotic arm scissors. The simple catapult you will make has a single lever while the lazy tongs and robotic arms have multiple levers. Figures 3.4 and 3.5 show the steps for making a catapult and robotic arm respectively using waste materials. Working model of catapult. Materials. You will need ice cream sticks, rubber bands and an ice cream spoon. Step 1. Stack about 5 to 6 ice cream sticks, one on top of the other, and hold them together with rubber bands, one on each end. Take 2 other ice cream sticks and hold them together at one end with a rubber band. Step 2. Place the 2 sets of ice cream sticks as indicated in the figure. Step 3. Using a rubber band, attach the ice cream spoon as shown in the figure. Your catapult is now ready. Figure 3.4. Steps for making a catapult using ice cream sticks and spoon. In this page, there are images of the steps of making catapult using ice cream sticks and spoon. Page 64. Working model of robotic arm. Materials. You will need ice cream sticks, glue, old bottle caps, toothpicks and a cutter. Step 1. Pierce the ice cream sticks in the center. Break a toothpick into small pieces and join the ice cream sticks by passing this piece through the holes. Remember to add glue where the sticks are joined. Step 2. Join a few more ice cream sticks just like in step 1. There needs to be a free movement of the ice cream sticks. Step 3. Cut out the centers of the bottle caps with the cutter so that you end up with 2 circular shapes. Step 4. Glue the bottle caps to the ends of the first set of ice cream sticks. Your robotic arm is ready. Figure 3.5. Steps for making a robotic arm using ice cream sticks, bottle caps and toothpicks. In this page, there are images of the steps for making a robotic arm using ice cream sticks, bottle caps and toothpicks. Page 65. 1. Draw a sketch of the toy giving accurate measurements where different parts are connected. You can paste a photograph of the toy in the space given below. 2. Write down the instructions for someone who is using robotic arm for the first time. Write the instructions in the given blank space. Activity 3. Using a propeller to make toys. A propeller is a wheel with blades. As the wheel moves, the blades help movement by pushing through water or air. You can make an elastic band boat using a propeller. Figure 3.6 shows the steps for making an elastic band boat using waste materials. Page 66. Working model of a propeller boat. Materials. You will need ice cream sticks, glue, straw, bottle caps and rubber bands. Step 1. Paste ice cream sticks in the shape as indicated in the figure. Step 2. Paste additional ice cream sticks to make a boat shape. Make holes as indicated by the dots in the figure. Step 3. Make slits in the bottle caps. Cut and paste ice cream sticks to the sides to make a propeller. Step 4. Pass a straw through the caps and the holes in the side of the boat as indicated in the figure. Step 5. Paste a rubber band at the tip of the boat and to the middle of the straw. Step 6. Wind up the rubber band using the paddle wheels and place in water. Your boat is ready. Figure 3.6. Steps for making a propeller boat. In this page, there are images of the steps for making a propeller boat using materials like sticks, glues, straw, bottle caps and rubber bands. Page 67. 3. Draw a sketch of the toy giving accurate measurements where different parts are connected. you can paste a photograph of the toy in the given space. 4. Write down instructions for someone who is using Propeller boat for the first time. Write your instructions in the given blank space. Activity 4. Using a wheel and axle to make toys. Wheel and axle is a simple machine that is made up of wheels held together by a rod so that they move together. In this way, if you have two wheels and axles, they balance each other and can move loads of any sort of shape placed above them. Car wheels are an example of wheel and axle. Some toys you can make using two sets of wheel and axle are rubber band car and air balloon car. Page 68. Rubber band car. Materials. You will need clothes clips, straws, chopsticks or toothpick, bottle caps, cellophane tape, scissors, rubber bands and glue. Step 1. First cut a straw of length so that you can join the two clothes clips slightly far apart. Step 2. Make holes in the exact centers of 4 bottle caps and attach them to a toothpick or piece of wooden skewer to act as wheels for the clothes clips. Attach one cap, pass it through the straw at each end and then attach the other cap. Remember to use glue to hold the bottle cap and toothpick or part of wooden skewer together. Step 3. Attach a small part of a toothpick or chopsticks between one set of wheels. You will have to glue it to the straw. This is the front of the car. On the other end, loop a rubber band over the straw. This is the back of the car. Step 4. Pass the other end of the rubber band over the small piece between the wheels at the back of the car. Step 5. Wind up the rubber band at the back of the car and release it on stable ground. Your car is ready to race. Figure 3.7. Steps for making a rubber band car. In this page, there are images of the steps for making a car using different materials like clothes clips, straws, chopsticks, cellophane tape, scissors, rubber bands and glue. Page 69. Air balloon car. Materials. You will need flexible straws, an old plastic bottle, old bottle caps, cellophane tape, a rubber band, chopsticks, balloon and glue. Step 1. Tape the chopsticks onto the bottle as shown in the figure. Step 2. Make holes in the bottle caps and attach them to the chopsticks as indicated in the figure. Remember to use glue to ensure they stay attached. Step 3. Fix the balloon to one end of the straw with a rubber band. Step 4. Make a hole in the bottle and insert the straw as indicated in the figure. Working Model 1. Blow the balloon from the open end of the straw and then press your finger to the straw. Place it on an even surface. Working Model 2. Release your finger. Your balloon car is ready to move. Figure 3.8. Steps for making an air balloon car. In this page, there are images of steps for making an air balloon car using materials like old plastic bottle, old bottle caps, cellophane tape, chopsticks, balloon and glue. Page 70. 1. Paste a photograph of the toy that you created in the given space. 2. Write down the instructions for someone who is using air balloon car for the first time. Write down your instructions in the given blank space. Activity 5. Using more than one simple machine to make toys. A windmill is a machine that generates energy from wind. A real windmill is made up of many parts. But your working model of windmill can be made by using a combination of simple machines like propeller and wheel and axle, along with other parts to make these machines work together. Figure 3.9 shows the steps for making a windmill using various materials. Page 71. Windmill. Materials. You will need pieces of cardboard, chart paper, straws, glue and a cutter. Step 1. Make a cardboard box as shown in the figure. Make holes in the center of the sides and pass the straw through the holes with a circular piece of cardboard passing through it. Step 2. Attach another circular piece of cardboard of the same size to the other end of the straw. Stick a small piece of straw to the cardboard circle outside the box. Step 3. Repeat step 2 for another side as indicated in the figure, except that now you must place the circular pieces of cardboard at the ends of the straw. Step 4. Make a cylinder with chart paper as shown. Make a fan with a short piece of straw, circular pieces of cardboard and blades cut out of chart paper. Step 5. Assemble the pieces as shown in the figure. You now have a working windmill. Figure 3.9. Steps for making a working model of a windmill. In this page, there are images of steps for making a windmill using cardboard, chart paper, straws, glue and a cutter. Page 72. 1. Draw a sketch of the windmill with accurate measurements of different parts. You can paste a photograph of the toy in the given space. 2. Write down the instructions for someone who is using the working model of windmill for the first time. Write down the instructions in the given blank space. Using ChatGPT for ideas. ChatGPT is an AI chatbot, a smart intelligent assistant. This AI tool uses information available on the internet to answer your questions. Ask ChatGPT for ideas on using waste material to make fun things. You may be surprised by what it comes up with. Page 73. Activity 6. Simple machines in a bicycle. So far, you have learnt about different forms of simple machines. You will now explore how simple machines are used to create a bigger machine. A bicycle is made using different simple machines such as wheels and axles, levers and pulleys. Figure 3.10. In this activity, you will learn about the parts of a bicycle and how to keep them functioning. Bicycles have many moving parts that work together to accomplish a task. Table 3.2. All the parts, wheels, gears, pedals, etc. of a bicycle work together to transform the effort of a rider into motion. Figure 3.10. Parts of a bicycle. In this page, there is an image of a bicycle with the names of its different parts like wheel, sprocket, pulley, wheel and axle and lever. Table 3.2. Parts of a bicycle and their function. In this table, the names of the different parts of a bicycle are given along with their function given on the right side. Brake pads. They are placed around wheels and they grab them to resist their motion. Brakes. They slow down or stop the bicycle. The different types of brakes are rim brakes, disc brakes and drum brakes. Chain. It transfers power to the rear wheel. Chain rings, sprocket. They guide the chain and transmit power from pedal to chain. Frame. This is the main structure that supports the rider and connects all the parts. Handlebars. They provide a place to hold and steer the bicycle. Hubs. These are the central part of the wheel. They allow the wheel to spin around the axle. Kickstand. It enables the bicycle to stand upright. Cycle light. It improves visibility and safety. Pedals. They are the point of contact for the rider's feet to apply force. Rims. They support the tires and provide braking surface. Rim brakes. Saddle. This is where the rider sits. Seat post. This connects the saddle to the frame, usually of adjustable height. Spokes. They connect the rim to the hub and provide strength and stability. Tires. They provide traction and cushioning. Some common problems and solutions related to bicycles are: 1. Rusting of parts. You can clean the parts using sandpaper and apply oil or paint as appropriate. 2. Loose parts. You can fix them using the appropriate tools. Ask your teacher which tools are used and write them here. Write them on the given blank space. 3. Wheels not moving freely. Oiling of moving parts will help. Page 75. 4. Flat tires. Air pressure in tires should be checked regularly to avoid flat tires. Now, let us look at each part of the bicycle more closely. As mentioned earlier, the bicycle is made up of different kinds of simple machines. To ensure that it keeps running smoothly, you need to check its parts and maintain them regularly. Figure 3.11. If needed, you can ask help from experts in the bicycle repair shop. Fill table 3.3 with the help of your peers and teacher. Figure 3.11. Working on keeping a bicycle in good working condition. In this page, there is an image in which school students are fixing their bicycle using tools. Table 3.3. Fixing parts of a bicycle. In this table, there are 4 sections. The first section is of the parts of the bicycle. The second section is functioning of part. The third section asks, is the part functioning well? You have to answer yes or no. The fourth section asks, did you do anything to fix the part? You have to answer yes or no. The names of the parts of the bicycle given are brake, chain, spokes, kickstand, handlebars and tire. You have to fill this table according to your needs. Page 76. Activity 7. Visit to a bicycle repair shop. You must visit a bicycle repair shop to learn from the experts. You can also request your teacher to invite a bicycle mechanic to the school to teach you all about maintaining and repairing a bicycle. Some questions you can ask the mechanic are given below. 1. Is there anything that should be regularly checked before riding? Write your answer in the given blank space. 2. Can the saddle height be adjusted? How? Write your answer in the given blank space. 3. What is the best way to clean a bicycle? Write your answer in the given blank space. 4. How do you know that the tires need to be inflated? Write your answer in the given blank space. 5. How is a punctured tire repaired? Write your answer in the given blank space. Page 77. 6. How often should a bicycle chain be oiled? Write your answer in the given blank space. 7. How can the squeaking brakes of a bicycle be fixed? Write your answer in the given blank space. 8. How are the wheels of a bicycle aligned? Write your answer in the given blank space. Activity 8. Organize an exhibition of the toys. Planning an exhibition of toys made by you and your peers in a school can be an exciting and enriching experience for all students and visitors. Take the help of your teacher to plan and organize the exhibition. The following are some tips to guide you to organize such an event. 1. Define the purpose of the exhibition. It is to raise awareness about the toys, showcase creativity, or teach how to make toys using waste materials. For example, during the exhibition, you can demonstrate the skills of making toys. Page 78. 2. Decide on a theme for the exhibition. Example, eco-friendly toys, historical toys and futuristic toys. 3. Ensure that the toys made by you all align with the chosen theme. 4. Decide on the exhibition space within the school. 5. Plan the layout of the exhibition, ensuring there is enough space for each toy and for visitors to move around. Decorate the venue in line with the theme to create an engaging atmosphere. 6. Send invitations to parents, local artists and community members. 7. Arrange the toys attractively, ensuring each has a label with the creator's name and a brief description. Ensure all toys are safe to handle and the venue is child-friendly. 8. Have volunteers supervise the exhibition to assist visitors and manage any issues. 9. Collect feedback from visitors, students and teachers to understand what went well and what could be improved. 10. Take photos and videos to document the event and share highlights through the school's newsletter or website. What did I learn from others? Name any 3 things you learned from your friends while making toys or working models. Write your answer in the given blank space. Name any 3 things you learned from the expert. Write your answer in the given blank space. Page 79. What did I do and how long did it take? You translate your ideas into actions. It is important to understand how much time is required for an activity to be completed. Calculate the approximate number of periods you spent on each activity. Mark them on the timeline below. If you did more than the activities suggested in the book, please add the number and time taken. In the timeline, mention the time taken in terms of periods of the different activities you did. What else can I do? Make a chain reaction machine using different kinds of simple machines made from trash. You can search on the internet for ideas using the following search keywords: simple machine plus chain reaction toy. Think and answer. 1. What did you enjoy doing? 2. What were the challenges you faced? 3. What would you like to do differently? 4. Design a toy that you can use to help a peer understand a concept related to mathematics or science. Page 80. 5. You can estimate the number of times the wheel will rotate when covering a distance of 10 meters. Hint: you can either use the circumference of the rim of the bicycle tire or observe the movement of the bicycle tire. 6. Can using a bicycle make a difference to our health and the environment? If yes, how? 7. What jobs are related to the project? Look around, speak to people and write your answer. A few examples of jobs related to the work you just did are bicycle mechanic, toy maker and engineer. Chapter ends.
You were just listening to this audio book, Textbook of Vocational Education for Grade 6. Narration: Farhan Ali Naqvi. Sound recordist: Virendra Rawat. Assistance in production: Amarjit Sarkar. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.